Okay. Thanks a lot for organizing the conference and putting this paper on the program. So before I start, I just want to say, one very, quick word about Emmanuel's generosity. So I was not Emmanuel. Unlike many people here, I was not his student. I was not his junior colleague. I was not his co-author. When I met him, I was not even an economist. And yet he was very, very generous with his time, whether I wanted to talk to him about a paper, whether I asked for career advice. And you may not believe it, but a few occasions about relationship advice. He was very, very generous with his time. So many things I learned from him are going to stay with me for a long time. So this paper is very much related to the paper that David presented, and later on some of the other papers we see. So and it's going to be a pure theory paper. But let me start with a little bit of just one graph, basically, which is not going to be very surprising for you. That if you look at that the number of exits of firms or establishments in the U.S. or probably anywhere, it's very much counter-cyclical. During recessions, you get many more firm exits than during normal times. And you can wonder whether this matters for aggregate. David just made an argument that entry and exit is very important for the aggregate. And you want to ask whether these entry or exits can matter for business cycles. One perspective you can take is that, well, it doesn't matter if some firms exit or not. Specifically, in many models, firms that exit are the least efficient ones. So on the margin, obviously, you're going to be losing some firms, you're going to be losing some production capacity, but these are the least efficient ones. So maybe in that sense, it doesn't really matter, if you want to think about this exit or not. On the other hand, you can think that, well, maybe these firm exits can can take the opposite perspective, say that these firm exits can be quite important. So, just to get a sense, everybody's now talking about that, you have supply chains are quite important for production. If you have any sort of disruption to the supply chain, it can actually have a first order effect. And, just to get a sense of how large, these relationships are, how durable these are, if you look at Belgian data, it turns out that 83% of inputs purchased by Belgian firms are from continuing suppliers. So there are very persistent relationships between supplier and customers. So if you buy the premise that there is some value being created in this, or there is some value in these relationships, you can imagine if these relationships are being destroyed, then they can potentially have a significant effect. So what we do in this paper, we want to think about this, take this input-output relationships at the firm level and this surplus created between these firms seriously. So we're going to develop a model of firm-level supply chain. So it's going to be very much related to what David was talking about, in which firm-specific relationships are going to contribute to productivity. And when you have disruptions to the supply chain, essentially some of this value is going to be destroyed because these relationships break. And so as I say, it's going to be more of a theory technical paper, which we're going to think about existence, uniqueness, and then I'm going to give you some competitive static results. And what sort of the result which this model was written to deliver is that these you should not ignore these relationships and how they respond to shocks, whether they can persist or whether they break. So on the methodological side, when we want to besides writing down the model, one view that we have of the methodological contribution of the paper is that as soon as you start thinking about taking these firm level relationships seriously, you realize that especially when you start thinking about markups, that there would be both strategic substitutability and complementarities in firms' entry and exit decisions. And that sort of complicates the analysis. So there are going to be two sources of at least strategic substitutabilities that makes existence and uniqueness results sort of tricky. On the one hand, obviously, a more productive supplier can steal business from a less productive supplier. So if David enters, his entry can actually hurt me. That means if we are competing. So we're going to shut down, so we don't have a methodological contribution there. We're just going to shut down that channel by assuming that all inputs, with some caveat, are going to be are going to be gross complements. But there is a second effect here, is that if David enters, and he is actually, let's say, he's going to be consuming more resources that he contributes to the aggregate, but it's going to be bad for me as well, because of a general equilibrium effect. If David enters and uses a lot of, for example, labor for production, that's going to hurt me because a lot of resources are being taken out of the economy. So there, this is another source of strategic substitutability. So in order to be able to handle this, we'll develop a new fixed point theorem, at least to our knowledge new, that allows us to take this aggregate demand externalities into account. All right, so let me give you sort of like a cartoonish view of what the paper is about. This is not going to be a differentiable model, but it's going to be a discrete model, but sort of is a good way of thinking about, just to put it in the language that David was talking about. If you want to think about the impact of a shock on GDP, you can think of it, a decomposition of the following form. There's this first term here. There's this first term here in which you keep the production network fixed, and you think about, well, how would the shock impact GDP? Of course, there's going to be a shift in the production possibility frontier potentially. There are going to be all the reallocation effects that David talked about. Maybe there is a movement in markups. That's going to be in this term. What we're mostly interested in, is this second amplification effect. Is that when you get hit with the shock, potentially the production network changes. As I said, some of these productive relationships break, and that can have an amplification effect on GDP. Okay. So sort of most of the economics of the model I can actually try to explain it in this simple figure. The idea is that I'm going to have, imagine you have just a very stylized production network here. These are firms, and the key thing here is that these firms we're not going to be in a competitive world. These firms are basically sharing surplus. Maybe imagine there's some form of bargaining going around, and the surplus is divided between these firms. Now, if you take this firm J out, maybe because of a negative shock, obviously that's going to have some aggregate effect. But then these are the sort of amplification mechanisms that can happen in the model. First of all, this firm K may have to exit because it doesn't have a customer anymore. So that's going to be one mechanical, in some ways, amplification effect. There may be some downstream effect because I is losing a productive supplier. But maybe I doesn't exit. Maybe I can still survive without J, but that may still lead to the exit of L. The reason being that, well, if I lose a supplier, there's basically going to be less rents going around in this economy that I can share with my supplier, and that would lead to L's exit. And then you may have some GE or aggregate demand effects that lead to more failures. So that's sort of the general view of what the model delivers. In terms of what the paper relates to, as I said, this is related to the paper that David just presented, also the paper that Ben would present, and also because we have a model of trying to endogenize the markups, it relates to David Emmanuel's earlier paper on markup. I forgot to mention, by the way, this is one of the talks you can interrupt me, so I should have said it in the beginning. All right, so let me get to the model about how we do this. So this is going to be going to have an economy with n+1 industries. Industries 1 through n, these are going to be producing intermediate goods. Industry 0 is going to produce the final good. There's going to be two types of firms in each of the intermediate good producing industries. There's going to be a competitive fringe of firms that I'm going to call them generics. This is sort of like a fully competitive, it's like standard production network models are going to have these set of firms. What we add to the model is a collection of firms that produce some customized variants. Okay, and customization is where we want to capture this firm-specific relationships. If David is my customized supplier, there is some value in that relationship. And the household part is going to be completely boring. Okay, so first let me tell you these generic producers. As I said, it's going to be a competitive fringe of them, and I'm going to index them by B. These are like lower quality firms. And the production function of these generic firms in industry I, it's going to be some constant returns to scale function. Then I'm going to use labor, input from other industries, and these B's are productivities, potentially pair-specific productivity of the generic producers. Okay, and I'm going to assume, as I said, that all these inputs across this are gross complements, so with an elasticity less than or equal to 1. This is basically, I'm going to shut down competition the way I mentioned. Now, the more interesting part for us are these customized producers. The customized producers is, as I said, they're going to be a finite collection of them. Yes.
So just
yes.
Understand these generics. They only use generics.
They only use generics.
So this is like how everything could survive if all the customized ones disappear.
Exactly.
This provides a lower bound.
Exactly. So these, I should have mentioned, as a generic, you only rely on generics. You sell to generics, but you will be able to sell to the customized guys. So this would be a lower bound of the entire economy, absolutely. The customized guys, on the other hand, they have these customized relationships. So if firm I is here, it can buy a customized input J, customized input K, and I'll show you now, it can always rely on the generics as well. I'm going to impose this assumption here, and that is that if you refer customized firm I, you can have multiple customized suppliers, but you're going to have at most one in each industry. Essentially, that's really killing the competition. I'm not going to have two customized firms competing for being my supplier in that industry. But of course, the generics are going to be there. So this is the production function of the customers, guys. So if I'm a customers firm in industry I have the same exact production function of the generics, except the following. So if I don't have a customized supplier in industry J, well, I have no choice but to use the generics, in which case I'm going to get productivity B. But if I do have a customized producer in industry J, then I have the choice. I can either go to the generics and get a productivity B, or I can go to my customized supplier in an industry and get a productivity A. And this wedge, I'm going to assume that A is bigger than or equal to B, and this wedge is going to capture the extent of customization. So the wider this wedge is, the more important is David for my production technology. Okay, so that's basically the general idea. Yes?
And the FI is the same.
It's the FI is exactly the same as before.
Because the A is just better.
The A is just better, yeah, if they're there. Exactly. The only downside of the A is that, you know, these firms have to pay a fixed cost. So you can always be generic, but if you want to be my customer supplier, you have to pay a fixed cost in order to get this extra boost in productivity. So you pay ZI units of labor at T equal to 0, and then this is going to be a sunk cost by the time you become my generic supplier at T equal to 1. And, you know, you can decide to pay this fixed cost, or you can decide not to pay it, and then that's where exit happens.
So if you're in a customized relationship, you have a bargaining ex-cost, or in the contract, how do you share the surplus?
Yes, by bargaining. I'm going to get there in a second.
You get in the bargaining.
Yes, exactly. The only thing that to keep in mind for now is that
this... monopoly,
exactly,
yeah.
Exactly. The only thing to keep in mind is that the ZI, the fixed cost, is sunk before, when you get to the bargaining. So you cannot bargain over ZI, but you can bargain over how the price is being shared. Okay? And then firms obviously...
You have the alternative as an outside option, I guess.
You can always go to the generic. Exactly. The generic...
So that will determine, that will influence the...
Exactly. I'll get that in a second. Yes. And then, you know, pay firms that don't pay that fixed cost, you know, they exit, and then you get this bold G as a subset of this script G. The script G was exogenous to given. Firms that don't pay it, they exit, you're left with this bold G. Okay? So there's a consumption goods sector. This is boring. I'm just going to skip it. The only thing is that these firms have no market power and no fixed costs, you know, so let me skip that. Okay, so the generic, now let me tell you about the terms of trade. The generic producers are trivial because they're competitive, you know, they price at marginal cost. The customers producers, on the other hand, they produce this surplus, and we are in this bilateral relationship, so we're going to assume that, you know, they're going to divide surplus via bargaining. Okay? So two active firms, suppose both, you know, Philippe and I have paid the fixed cost, we enter into a relationship now, and, you know, we're gonna, you know, at equal to, I don't know why that thing's moving, at equal to 1, and, you know, we're gonna write a contract between the two of us which is gonna specify the price. So the price is gonna be that, the contract, the way it's gonna be is that it's gonna be a commitment from the supplier to the customer to deliver as many units as the customer demands at that fixed price. So we bargain over the price, it becomes a commitment for next period. So let me be more specific. We're going to use some form of bargaining a la Rubinstein. So it's going to be a random offer alternative bargaining out game over infinitely many subperiods. Specifically, the supplier and customers, they're going to make offers to one another with probability delta and 1 minus delta. So you can think of delta as a proxy for the supplier's bargaining power, and 1 minus delta would be the customer's bargaining power. So David and I started our bargaining process. David makes me an offer. If I reject it, we do a random new draw, and then we can make another offer. We do this until one of us accepts the other party's offer. If we don't reach an agreement, you know, we cannot trade in the next period. Okay? And of course, as Philippe said, I, as a customer, always have the option of going to the generic.
Billmore will be side Bolinsky bargaining with the outside option direct without having to go into the detail.
Yes, so it's going to matter a little bit how the outside, so for example, if I do Nash bargaining also, it's going to matter, it's going to change how the outside option manifests itself. It turns out with Rubinstein we can get, you know, we can make, that's exactly right. Okay, so basically this is exactly, Philip, you know, anticipated all of this. So as I said, this bargaining power delta is going to determine all the markups, because that's how we're going to divide the surplus. So I'm going to give you a relationship as exactly how the markups are going to relate to these deltas. But the key thing to keep in mind that I always have this outside option as a customer to go to the generic. So the price that David and I can reach can never exceed this amount, my outside option, because if this is the price of the generic good, I'm gonna get a boost of A over B if I buy the customized. So that means that this price can never exceed that. Of course, both of us always have the outside option of walking away as well. You know, just I don't want to trade period. Okay, and then so basically this is essentially the summary of the model. At t equal to 0, you're given the network of these potential customized relationships. A subset of firms, they decide to pay the fixed cost and they enter, and then you get this big this bold G. At t equal to 1, we do this bargaining. The firms enter into these contracts, so obviously the generics are going to be via marginal cost pricing, and then the customers are going to be via bargaining pricing. And at t equal to 2, now all prices are fixed. Basically, firms optimize quantities and all markets clear. So this is when quantities are determined, prices are determined, entry is determined. Yes?
So here the TB is exogenous, right? Because like a sample no substitution.
Exactly.
That's why if our bargaining fails, I don't have to think that also affects the price.
That's exactly right. That's exactly. So exogenous to the extent that it only depends on the F's and the B's. The B. Yeah. But once you bracket that, exactly. So this is going to be exogenous to our bargaining process. That's exactly right. That's where the tractability comes from, really. That's exactly. Yes?
Might there also be an aspect of boundaries of firm and how we think about whether firms vertically integrate and own the supply of upstream and downstream aspects?
Yeah, so basically the way we think about it is that the boundary of the firm is where the bargaining happens. So that's what's in the model, that's sort of the definition of the boundary of the firm. So if you merge the two, essentially you now can efficiently, you just, bargain with the rest. So.
Do you think about the choice of whether?
Oh, I see. No. So we.
So vertical integration, you mean? Integration on that?
Right.
Yeah. No, so yeah. No, we don't think about that. We think about that choice. So we just take that as given, obviously. So yeah, I mean, I think we're far from where we want to be even with this model. So I'm just more hesitant to make it more complex. Anyway, so let me tell you the solution concept. The value of this is just to think about again how the model works. So this is just going to be backward induction at t equal to 2, where the quantities are determined. We're going to have a production equilibrium. A production equilibrium is going to be a collection. You take the prices and the network is given, and the quantities are determined. So firms are going to minimize cost while meeting the demand from their customers. The household is going to maximize their utility, and of course, all markets have to clear. This is just consistency in the quantity space. Then at t equal to 1, you go one step back. This is where prices are determined. This is where you now essentially have consistency in the price space. So bargaining equilibrium is a collection of prices and quantities, such that the quantities in the subgame, they form a production equilibrium. No generic producer can earn higher profits by offering a different price. Obviously, this is just marginal cost pricing. But then also, you don't want to deviate from the prices prescribed by the equilibrium to start a bargaining process. Essentially, is that if David and I have a price, I don't want to renege on this price and say, hey, David, let's rebargain our price. So essentially, all prices are also consistent with one another and with bargaining. And then at t equal to 0, this is where entry happens. That's essentially, it's going to be a full equilibrium now. It's going to be some network and prices and quantities, such that the quantities are a production equilibrium at t equal to 2, prices are a pricing equilibrium at t equal to 1, and no customized firm has an incentive to change its entry decision. So if you're firm I, and you are supposed to be active, you are indeed making positive profits. If you're a firm I that you're supposed to be inactive, by entering you're going to be making negative profits. Okay, so essentially no deviation here, no profitable deviation as well. Because this is the step that endogenizes the production network. Okay, so that's the model and the solution concept. So let me give you some of the results that we have. So first of all, let me give the t equal to 2, where the production happens. This is sort of standard result. That given the network and the prices of production equilibrium exists and is unique. Now, because of complementarity, sometimes this equilibrium is trivial, that no production happens. But let's forget that. Then now let me go to t equal to 1 and tell you how the prices are determined. So if I give you a feasible equilibrium G, so first of all, bargaining equilibrium always exists, and any two pair of firms, just like in Rubinstein bargaining, reach an agreement in equilibrium. All generic prices are going to be determined by a marginal cost pricing. So this is, as Ivan said, this is just a fixed point equation, and this gives you the non-substitution theorem. The customized prices, on the other hand, they're determined via bargaining via this relationship. So the price that I and J agree obviously cannot exceed this outside option. This is the outside option. And or it's if the outside option doesn't bind, it's going to be equal to this p hat, which is a solution to some equation. So this equation, which the bargaining powers and firm profits are going to show up, is going to tell you exactly what the price we agree on. So going back to what Philippe was asking, the reason that, so in this economy, if the outside option doesn't bind, because of Rubinstein bargaining, the outside option is irrelevant. If I were doing rash bargaining, the outside option would be relevant even when it doesn't bind. But that's sort of what gives us some tractability. So let me be a bit more specific what this equation does. If you have a CS production function, you can actually characterize this a little bit more nicely, and this is the relationship that you get. That if I is the supplier and sells to one customer J, in that relationship, the other way around. If J is the supplier and sells to I in that relationship, the markup that I charges is going to be related to the markup that J charges. Essentially, this is how we divide the surplus, which depends obviously on the bargaining powers. It's going to depend on the elasticity of substitution, and it's going to depend on the shares. These are the input-output shares, the cost shares of the customer firm. So basically, you can see how if you change these bargaining powers or the elasticity or the shares, how the markups are going to be determined. One thing to keep in mind is that this omega ij itself is still an endogenous object because it depends on the price that David and I agree. But if you go to a Cobb-Douglas, now this omega ij becomes a constant, and now you're going to get even a simpler relationship. So either Cobb-Douglas or Leontief, you can get even more tractable relationships for these values. But now this is going to give me all the markups I want throughout the economy. Okay. So now let me go back. So that was the characterization of the equilibrium as t equals 2, t equals 1, and now let me go to the full equilibrium. So I need two assumptions here. One is that if either all outside options bind or none of them bind, then I can give you this result that there is going to be a full equilibrium. So these entry-exit decisions, there's going to be an equilibrium there. And more importantly, the set of full equilibria is going to have the greatest element with respect to the set inclusion order. Essentially, there is an equilibrium with the maximal number of firms entering. And more importantly, GDP is going to be highest in that equilibrium vis-a-vis all other equilibria. So you may have many, many different equilibria because of coordination failures. Well, I'm not entering because Ivan's not entering. So this part B and part C says, you can ignore those equilibria because there's always an equilibrium in which there's maximal entry happening. And this result comes from the fixed point theorem I told you. Sort of is similar to Tarski's fixed point theorem, but it's different because we have these strategic substitutabilities from time to time. So the key thing, as I said, is that any failure in this greatest equilibrium are going to be fundamental. And what happens is that you just have to show that this mapping, which is the firm's entry decision best response mapping, is going to have a fixed point, a greatest fixed point, even though it's not a monotone map. I'll spare you the details of the fixed point theorem. All right. So now let me give you some comparative statics given the model. So basically, to do the comparative statics, it's much easier to define, look at a tree, because that would allow me to think about firms that are clearly upstream to a relationship and firms that are clearly downstream to a relationship. So take a relationship between firm I and J. I'm going to call these guys upstream to this pair. These firms downstream, and these firms are sort of, a lack of a better word, are horizontal to this relationship. And let me first do a simple comparative static with respect to the bargaining power. So David is my supplier, and I'm going to increase his bargaining power vis-a-vis me. The question is, what happens to the profits and markups and output in this economy? So it's going to increase all upstream markups. The reason being that, if David has a higher bargaining power, he's going to extract more resources from me. His markup is going to go up. But then now David has more resources, and his suppliers can extract more resources from him. So basically, there's going to be resources being more allocated to more upstream firms. And in the same way, all downstream firms are going to be worse off. Essentially, all their markups are going to go down. It's going to increase also all profits of upstream firms and decrease the profits of all downstream firms. It's not just the markups. Then you take the quantities into account, same thing's going to happen. And then you can get a similar result for prices. I think it would be easier to look at it here. So if you take this relationship between David and I, and suppose I increase this bargaining power. These firms' markups are going to go up, and these firms are all going to be worse off, essentially because resources are going to be extracted from I and whomever is below it. In some ways, this is a consequence of the pairwise bargaining. And same dynamic for prices. Now, let me go back. Now, this was for bargaining power. Now, let me give you a comparative static result on changing the network itself. So let me now I add some firms or remove some firms and see what happens there. So suppose all bargaining powers are equal to 1. This is going to give me tractability. And imagine I have two networks. One is G lower bar, which is smaller than G upper bar. So essentially, in G lower bar, I'm killing some firms mechanically. Under some condition, which I'm going to tell you, it's two things are going to happen. First of all firms are going to be making less profits, and aggregate output is going to fall. And this condition basically tells you that the firms that you're taking out, they were so basically this tells you that these are the firms that are in the wedge between the two firms that you're taking out. They were actually profitable firms. You're not taking away some negative value firms because otherwise this would have gone the other way. But basically it tells you that if you shrink the set of active firms, you're going to reduce profits and aggregate output. Again, sort of like a sanity check result telling you that when you take out firms, they take away production capacity with them. That means that, because these relationships are going to be destroyed, you have to rely on B technologies instead of the A technologies, and aggregate output falls. Obviously, this is something you would want from the model, but, we have to make sure that this actually holds. Because, we're far from the efficiency, so it's not, we have to worry about exactly how the misallocation happens. So here is a mechanical way of seeing that if I kill this firm J here, essentially all these firms are going to be worse off because this I now has to rely on the generic variant of J instead of J itself. Okay, so next thing I'm going to do a comparative static with respect to the productivity shocks. So imagine again I'm keeping the network fixed and I just change one of the productivity shocks, let's say AIJ. So this is going to be increasing aggregate output. It's going to weakly increase all markups because obviously, when the A goes up, the supply can charge a higher markup. It's going to increase the profits of all firms that are downstream or horizontal to J, but it may actually decrease the profits of some upstream firms. So it's easiest to again see it in this figure. So imagine I increase this productivity between I and J. Obviously, this relationship is more productive. J's profits are going to go up. So would these guys' profits are going to go up. But this firm can actually be hurt. And this is because if this productivity goes up, obviously firm J is now more productive. So to meet the demand from I actually would need less inputs. And that would mean that even though this price was going up because of bargaining, the quantity effect is going to overwhelm the price effect, and this firm is going to be worse off. This is really, again, coming from the non-competitive nature of the model. Essentially, you get this perverse quantity effect that an increase in productivity can actually reduce demand and reduce profits further upstream. Okay? Yes?
Why is my intuition wrong with that would depend on the elasticity being greater or less than 1?
Which elasticity?
Between J and the guy above him.
So here I'm just assuming that, this is his single supplier, so there's not even there's no substitution room here. So it's sort of the elasticity is irrelevant. But the way to think about this is that, so imagine I increase this productivity. Obviously, imagine aggregate output goes up. So aggregate output goes up, that means the demand for everybody is going to go up. Yeah. Okay? But the key thing is that the demand for this guy is going to, so the price is going to, so the demand for this guy, J, is going to go up less than 1 for 1 than the productivity. So even though imagine I am twice as productive, but my demand just goes up by 1.5 factor. That means that as a result, I need less inputs. That's basically what's happening.
But that's because they're complements, right?
Yes, that's because they're complements. Exactly. Yes. Yeah. Exactly. Obviously, yes. Yeah. That's because they're all the substitutability happens only. All the substitutability is in this generics. In the generics, when it comes to the customized, everything's complement. Or here is a different way of saying what David said. If I kill this firm here, so I had a full chain, then these two effects are fully cancel each other out, and this guy would see no effect. The fact that there is another input here, and this elasticity is less than 1, is going to mean that this guy is going to be worse off. That's right. Okay, so far all the results I showed you, I was taking the production network to be exogenous. So now I want to see what happens if I endogenize the production network. Essentially open up this entry-exit margin. So this is sort of, again, a result that you would want the model to deliver, is that if I increased firm-level fixed costs, some of them or all of them in the economy, it's going to shrink the set of active firms. It's going to lower aggregate output, and it's going to reduce the markups of all the remaining firms in the economy's greatest full equilibrium. So I've just focused on the maximal equilibrium. If you increase fixed costs, obviously some firms would exit. As they exit, they take away production capacity with them, and as a result, it's going to lower profits and lower output. And this is this is because there are complementarities in production. Obviously, part of it is just mechanical because of the direct propagation of these failures, and part of it is a GE effect. As firms exit, demand for many other firms in the economy goes down, and then it increases the more likelihood of exit there. Okay. So now with that, so I can even show the decomposition that I showed in the beginning. So if I want to see, suppose I change the fixed costs from
you
some.
don't have effects like some models when some firms exit, they all use labor, it reduces the cost, so it may reduce the entry cost, and other firms can enter. You see, I think you have this kind of reallocation models where some firms exiting can in fact make entry easier for more efficient, for potentially more efficient firms. You don't have
So basically there's a
channel you don't.
exactly. So all the firms are there. All the firms, obviously,
Yeah.
if you exit,
Yeah.
okay. So the key thing here is that when firms, the one thing I did mention is that the wage is really going to be determined by these generics. So in some ways, the entry-exit decision is not going to change. It's going to open. If you exit, more labor is going to be available for other firms to use or for production, but it's not going to change the wage because all of that is going to be pinned down by the generics. So in that sense, this channel is shut down. That's absolutely right.
Can I just ask a question? So I have this intuition that if a firm is choosing to operate, that it's sort of saving on labor for everybody else. Because if I'm privately profitable, that means that if I exist, it's better than if generic is existing because I'm going to use less labor and everything's complement, so I don't expand. And that allows everybody else.
Yes.
Okay.
That's exactly what's happening. So the key thing is that's sort of at the core of the model in some ways. So if you're a firm that's privately profitable, you want to enter, and the social plan, the rest of the firms will want you to enter. That in that sense, that's when the entry decisions are complements. If you're a firm that's privately loss-making, then then the entry decisions are substitutes. And the fixed point theorem tells you can ignore those bad cases. That's exactly what's happening. As long as you want to think about it. Okay, perfect. So let me show you this decomposition of how the two terms matter. So if I increase, let's say, and for this I'm just going to look at the Leontief case, which is going to make things my life easier. Imagine I increase the vector of fixed cost from some z lower bar to z upper bar. So from the previous result, I'm going to know that less firms are going to be active. So the set of active firms are going to shrink. And basically, I can do the following decomposition. The change in GDP is going to consist of two terms. One is that I keep the network fixed, and then I can take a look at this failure margin. And you can characterize both of these. Obviously, this is going to be a negative term because, if just there are more fixed costs, more resources are going to be spent on them, and that means that it's gonna reduce output. The second term is going to consist of the failure margin is going to consist of two terms. Basically, this is exactly what David was talking about. On the one hand, obviously, as firms exit, there is a change in the production possibility frontier. On the other hand, as they exit, they free up resources that can be used by other firms in the economy. In this economy, the sum of these two is going to be negative. So always, it turns out that the change in the production possibility frontier because of these firms' exit is going to dominate.
You don't have things that's more efficient than trucks.
Exactly.
You don't have that effect.
Absolutely. Exactly. That's exactly what makes this overall term negative, and makes this amplifies that also. Okay. So in that sense, this failure margin is an amplification mechanism. Okay. So and now I can do also the comparative static with respect to the productivity, allowing for the endogenous network. So if you increase the productivity, as long as this, and this is an important caveat, if this firm J does not have any active supplies, then again, an increase in productivity is going to increase the set of active firms, it's going to increase firm profits, it's going to increase aggregate output. Same intuition as before, just more productivity, more active firms, you're going to get a higher output. And that caveat is important because of that perverse quantity effect I told you. So imagine I increase the productivity between this pair of firms 1 and 3. So suppose this relationship becomes more productive. As I said, for now take the network to be exogenous, as I said, these firms 2, 3, and 4 are going to be better off, but these firms, 2 and 3 are going to be better off, but firms 4 and 5 are going to be worse off because of that perverse quantity effect. Now, if I turn on the failure margin and allow some of these firms to fail potentially, as I increase this productivity, because the profits of 4 and 5 go down, actually these firms may exit. Now, depending on the relationship between what the gap is between the generics and the customized, overall output may go down depending on whether the firms that go out were extremely productive or not. Because of this inefficiency that resources cannot be fully we cannot efficiently negotiate rents throughout the chain, you may actually get that a positive shock can be recessionary here, just because of the failure margin. So let me end with an example which sort of like gets some of the effects in the model. So imagine I have a production chain here, and imagine all these customized productivities are the same, all these customized productivity B are generic productivities are the same, and all bargaining powers are the same. Okay, and imagine this firm 1 is the only firm that has a non-zero fixed cost. Okay, so this is the only firm that can potentially exit. Of course, this is a very stark example. Okay, so first let me look at the GDP in this economy. It's going to be given by this relationship. So if firm 1 doesn't exit, it's going to use Z1 units of labor for production, and I have n of these firms on top of one another. So this is going to be my TFP times the labor resources. If this firm does exit, then I'm going to fall from a productivity big A to productivity big B. So this is going to be my output. Now, what's going to determine this margin of exit? It's going to be, of course, dependent on the wedge of A over B and the bargaining powers. Okay, so you can see that as I change this n, the length of this chain, two things happen. On the one hand, I'm going to get a bigger wedge. Where I'm going to get a longer chain, means that I'm going to have a much more productive production here. So that's going to increase this. But on the other hand, it's also going to shift this failure margin. So it turns out that if some condition holds on the bargaining power, the Z tilde is going to be decreasing in n. So as I make the chain longer and longer, it becomes more and more productive, but at the same time becomes more fragile, because it's more likely that this firm 1 would exit. Okay, because more of the resources are being extracted by essentially I have more mouths to feed up the chain. That means that this firm 1 is going to can potentially be making lower profits. So in the one hand, it's sort of like a feature of this non-competitive model that this longer chain has a greater production capacity, but at the same time becomes more fragile. And as I said, because of the non-competitive nature of the economy. All right, so I don't know how much time I have. Oh, okay. So I can actually wrap up here. Essentially, one thing I want to mention is that in this model, exit happen. You can get these very stark effects because the firms that exit are the more productive ones. So essentially, if you have a shock here, the A firms exiting and the B firms are always there. So you can potentially get these relationships are very valuable. So it's the more efficient firms that potentially fail due to this when the supply chain shocks happen. All right, so let me sum up basically. The way we want to think about this, that you want to think about, we try to write down a model which takes this firm level relationships, pairwise relationships seriously. And once you think about that you have this customized relationship, you want to move away from the competitive benchmark, you want to take the bargaining problem seriously. That's going to allow us to characterize the markups up and down the chain. And when you open up the failure margin, you can have significant effects because as firms exit, they take away this production capacity with them. So let me stop here.
Thank you very much.